What if everything you thought you knew about the Moon was wrong? What if a hidden world was silently orbiting Earth, completely invisible, undetected, and closer than the stars themselves? Could a secret moon be drifting in our back garden, quietly changing everything we understand about the night sky? For centuries, humanity has gazed at the Moon with awe and familiarity. We've measured its phases, charted its path across the sky, and observed its influence on tides and the rhythms of life. The Moon has been our constant companion, a celestial guardian in the darkness, a silent witness to human history. We have sent explorers to its surface, landed machines on its regolith, and analyzed every crater, ridge, and shadow in painstaking detail. In our minds, the Moon was singular, alone, the undisputed ruler of Earth's orbit. And yet, modern astronomy suggests that this long-held belief might be incomplete. Earth may have a second secret companion, a small, elusive moon drifting silently through space, hidden from view, yet present in the gravitational theater of our planet. The story begins with subtle anomalies, barely noticeable at first. Astronomers tracking near-Earth objects, the countless rocks and debris floating through our solar system, started noticing irregularities. Tiny nudges, slight deviations, patterns that seemed almost deliberate. Initially, these anomalies were dismissed. In the chaotic environment of space, errors are common. Telescopes misalign, data is imperfect, and gravitational calculations are never entirely exact. But as the evidence accumulated, a picture began to emerge. A shadowy presence, whispering its existence through the faint tug of gravity. Something was there, something moving, hidden, persistent. Unlike the familiar Moon, this second companion would not be easily observed. Its size is modest, perhaps only a few hundred meters across, maybe even smaller. Yet size in space is deceptive. A body this small can follow a complex, unpredictable path, influenced by the gravitational interplay between Earth, the Moon, and the Sun. Its orbit would be erratic, sometimes lingering near Earth for months or years, only to drift farther away, invisible to all but the most sensitive instruments. Unlike the Moon's stable comforting cycle, this secret wanderer would be restless, weaving a path that challenges our understanding of orbital mechanics. The implications of such an object existing are profound. Even a small moon can subtly influence the dynamics of the Earth-Moon system, affecting space debris, satellite orbits, and perhaps even the tides over millennia. The thought that something could exist in our immediate cosmic neighborhood, unseen yet impactful, reminds us that the universe does not reveal its secrets willingly. We tend to assume the sky is static, predictable, orderly, but space is a theater of chaos, and even the familiar can surprise us. Consider the history of lunar observation. Ancient civilizations charted the Moon with remarkable accuracy, noting its phases, eclipses, and movements. During the Renaissance, telescopes revealed craters and mountains on its surface, a world previously hidden from human eyes. In the 20th century, satellites and lunar missions mapped it in unprecedented detail. Yet even with such scrutiny, an object just a few hundred meters wide could slip through, especially if it moved in a highly irregular orbit. Modern instruments are sensitive enough to detect asteroids only tens of meters across, and still, small objects occasionally evade detection. The cosmos is vast, and even in our immediate back garden, mysteries remain. Why has this companion gone unnoticed for so long? The answer lies in its size and nature. Unlike the Moon, which reflects light brightly, this hidden object is small, dark, and often positioned against the glare of the Sun or the backdrop of distant stars. It does not announce its presence. Its path is fleeting, sometimes near Earth, sometimes far away, following a pattern shaped by chance encounters with gravity over millions of years. Finding such an object is like detecting a single grain of sand moving across a desert while blindfolded. Yet patient observation, careful tracking, and the accumulation of countless data points have begun to reveal hints of its existence, whispers of a secret in the darkness. The idea of a second moon forces us to reconsider what we know about Earth's place in the solar system. Could it have been captured from the asteroid belt? Might it be a remnant of a collision billions of years ago? Or is it a wandering fragment from the early solar system, drifting until it became trapped in Earth's gravitational web? Each scenario carries profound consequences, not only for the history of our planet, but for our understanding of planetary dynamics across the galaxy. And the existential question remains, if this object exists, what does it mean for us today? Could it pose a threat, however small, to the Moon or even to Earth itself? Could it collide, destabilize, or influence our environment in ways we cannot yet imagine? Or is it destined to remain a silent companion, a ghostly presence moving unseen but undeniably real, a testament to the hidden wonders of the universe? The universe whispers secrets in the darkness, and this hidden moon may be one of the most astonishing. Tonight, we begin the journey to uncover its story, the tale of a silent companion, a cosmic wanderer, and the invisible threads that bind the solar system together. By the end, you may never look at the night sky the same way again. Every shadow, every faint speck of light may carry a story waiting to be told. As we delve deeper, the boundaries between the known and unknown will blur, revealing the astonishing reality that Earth, our seemingly familiar world, may be hiding companions that have slipped beneath the notice of human eyes for millennia.
Just when you thought the night sky was familiar, just when the moon seemed the only companion to Earth, the universe reminds us how little we truly know. Imagine looking up at the sky tonight, unaware that a silent, unseen traveler might be gliding through the darkness, orbiting our planet in a ghostly waltz. How could such a second moon exist, and what invisible forces could allow it to remain hidden for so long? To understand this, we must first explore the delicate dance of gravity. Every planet, moon, and asteroid is caught in a complex web of gravitational pulls, tugging and twisting objects along paths that can be surprisingly unpredictable. While the moon follows a stable, almost perfectly elliptical orbit around Earth, other objects can be captured temporarily, held by Earth's gravity just long enough to drift alongside us before escaping back into the void. These objects are known as temporary moons or quasi-satellites. A quasi-satellite is not truly a moon in the traditional sense. It doesn't orbit Earth in a fixed path like our familiar moon. Instead, it appears to orbit us because it moves in tandem with our planet around the Sun. From a distance, it can seem to loop around Earth, only to drift away after months or years. The gravitational ballet that governs its motion is incredibly delicate. Slight changes, perhaps a nudge from the moon, a tug from the sun, or a close pass by another planet, can send it spiraling away or back into the Earth-Moon system. Some hidden companions may be captured asteroids, wandering the solar system for millions of years until they pass close enough to Earth. If their speed and trajectory are just right, Earth's gravity can snare them temporarily, creating an invisible moon in the sky. These captured fragments may be small, irregular in shape, and extremely dark, reflecting very little sunlight, which makes them almost impossible to spot with conventional telescopes. They move silently, their presence betrayed only by tiny deviations in the orbits of nearby objects or faint glimmers picked up by infrared sensors. And yet, size is not the only factor that determines detectability. Orbital eccentricity, inclination, and distance from Earth all play a role. An object may spend most of its time on the far side of our planet, in shadow, blending with the cosmic background. Its orbit may be highly elongated, sometimes bringing it close to Earth and then flinging it far into space, like a celestial pendulum. For astronomers, finding such a moon is akin to tracing the path of a single snowflake in a blizzard while blindfolded. Some scientists have speculated that a second moon could be a remnant of Earth's own violent past. Billions of years ago, during the chaotic early days of the solar system, Earth endured collisions with massive objects, some large enough to eject debris into space. Could one of these fragments have achieved a stable orbit long enough to persist into the present, quietly shadowing our planet for millennia? The evidence is scarce, but the possibility adds a tantalizing layer of mystery. Perhaps the second moon is a relic of an ancient collision, a witness to the birth of our planet itself. Then there are the chances of interlopers, objects that wander from the asteroid belt or even further afield, nudged by the gravity of Jupiter or the Sun, until they pass close enough to Earth to be captured temporarily. The process is rare and precarious, but space is vast, and even rare events can occur. Once captured, these objects may oscillate between near-Earth space and deep interplanetary space, their orbits governed by subtle gravitational interactions that are almost impossible to predict without long-term observation. The more we learn about quasi-satellites, captured asteroids, and temporary moons, the more we realize how little we truly know about our cosmic neighborhood. There could be dozens of small companions drifting near Earth, invisible to the naked eye, yet shaping the gravitational dynamics of our planet and moon in ways we cannot yet fully measure. Every pass, every tug, every near miss is a story unfolding silently, hidden in the vast darkness beyond our atmosphere. And here lies the ultimate mystery. Even with the most advanced technology, we have only glimpsed a fraction of these objects. Some could be close right now, hidden in the glare of sunlight or the shadow of the moon, moving silently across the heavens while we sleep. Their paths are unpredictable, their presence fleeting, and their discovery is a reminder that even in the skies above our familiar world, the universe continues to surprise. This is the invisible ballet of space, a dance of orbits and gravity, of wanderers captured and lost, of objects that challenge our perception of the Earth-Moon system. The more we investigate, the more questions arise. Could one of these hidden companions linger long enough to become a permanent fixture? Could it eventually collide with the Moon or even influence Earth? The answers remain elusive, but the hunt has begun, and every new observation brings us closer to understanding these silent travelers.
Just when you think the night sky is familiar and predictable, imagine a silent wanderer circling Earth, unseen yet very real, moving along a path invisible to humanity for centuries. What would happen if this secret companion ventured too close? Could it disrupt the balance we take for granted, or even pose a danger to life on Earth? To understand the stakes, we need to consider the subtle yet powerful influence of gravity. Even a relatively small object, only a few hundred meters across, can have dramatic effects if its orbit brings it close enough. The Moon alone governs the tides, influences the planet's rotation, and stabilizes the axial tilt that gives us seasons. Introduce a second moon into this delicate system, and the calculations become far more complex. Astronomers warn that if a hidden moon were to stray closer to Earth or intersect the Moon's orbit, its gravitational pull could cause minor yet measurable effects. Tidal forces could shift slightly, triggering unusual patterns in the oceans. Satellites, carefully positioned to maintain communication and navigation, could experience unexpected perturbations. And though the likelihood of a catastrophic collision is extremely low, the very possibility reminds us how fragile the orbital dance around our planet truly is.
Some models suggest this wandering companion could have already passed near Earth multiple times over the centuries, its presence barely noticed because of its size and faintness. Each near pass is like a whisper of the universe's chaotic potential, a reminder that even a small object can carry consequences that ripple across vast distances. Could it, for instance, nudge the Moon into a slightly different orbit over millennia? Or could it act as a seed for future collisions, attracting or deflecting asteroids that might otherwise never threaten Earth? Then there is the unsettling thought of direct impact. If a hidden moon were to break apart, whether through gravitational stresses, collisions with meteoroids, or tidal forces, it could produce fragments large enough to enter Earth's atmosphere. Most would burn up harmlessly, but some could reach the surface, creating impacts that, while not globally catastrophic, could be devastating locally. This is the hidden danger of even the smallest celestial wanderers, a reminder that space, while majestic, is never entirely safe. Yet the potential is not purely dangerous. Some scientists speculate that such a moon could also offer opportunities for discovery and exploration. If captured and studied, it could reveal secrets about the early solar system, the materials that formed Earth, or even the processes that allow planets to capture and lose companions. It could serve as a natural laboratory, a cosmic time capsule preserved in orbit, waiting for humanity to reach it. Beyond tangible threats and opportunities lies the philosophical impact. A second moon challenges our perception of Earth's place in the cosmos. We imagine ourselves at the center of a stable system, yet even here, in our familiar neighborhood, the universe hides surprises. It serves as a reminder that the cosmos is not static. It is a realm of constant motion, of unseen travelers, and of forces beyond our immediate comprehension. Perhaps most unsettling is the uncertainty. We do not know how many hidden moons could exist, how long they might remain in orbit, or how they interact with the countless other objects drifting through near-Earth space. For all we know, Earth could have hosted these silent companions for centuries, shaping our planet's history in subtle, invisible ways. The moon we see each night may have always had a shadowy counterpart, a reminder that even in the sky above, the universe guards its secrets jealously. The hunt for this hidden moon is more than an exercise in astronomy. It is a confrontation with the unknown. It forces us to confront the delicate balance of our solar system, the randomness of celestial encounters, and the humility that comes with recognizing that even the most familiar sky can hold secrets we have yet to uncover. Every observation, every simulation, every discovery brings us closer to understanding these wandering companions, yet for now they remain enigmatic, silent, and tantalizingly just out of reach. As we continue our journey into this cosmic mystery, the questions grow deeper. Could this hidden moon one day reveal more companions lurking nearby? Could its discovery change the way we explore, protect, and interact with space? And as we peer into the heavens, the faintest glimmers in the night sky may no longer seem ordinary. They could be the first signs of worlds quietly orbiting, hidden in plain sight.
Just when you think we've seen it all, the mystery of a hidden moon is only beginning. Humanity has always looked to the heavens with a mix of wonder and determination, driven by the desire to uncover what lies beyond our comprehension. And now, armed with the most advanced technology ever developed, astronomers are attempting to reveal what has remained invisible for centuries. But how do you find an object that is small, dark, and constantly shifting against the backdrop of a vast star-strewn sky? Detecting a hidden moon is far from simple. Unlike the familiar moon, which dominates the night sky with its brightness and sheer size, a secret companion is faint,
elusive, and often lost in the glare of the sun or the shadow of the Earth. Its orbit is irregular, unpredictable, and restless. Sometimes it drifts close to Earth only to retreat far into the void, remaining hidden for months or even years before reappearing briefly in a position that may coincide with millions of background stars. Observing it requires patience, precision, and a touch of luck, an extraordinary combination of technology and human perseverance. One of the primary techniques employed by astronomers is gravitational microlensing. This phenomenon occurs when a massive object bends the light from stars behind it, creating a subtle distortion that can be detected from Earth. It is akin to noticing the ripple caused by a pebble dropped into a pond, even if you cannot see the pebble itself. Microlensing has already revealed countless distant exoplanets and may now provide clues about objects orbiting our own planet. Detecting these tiny ripples in the fabric of starlight requires extraordinarily sensitive instruments and meticulous observation over extended periods. Another method relies on infrared surveys, which detect the faint heat emitted by even the smallest, darkest objects. While a hidden moon may reflect almost no sunlight, it absorbs energy and re-emits it as infrared radiation. Sensitive instruments can capture these weak thermal signatures, highlighting objects that would otherwise remain invisible to optical telescopes. Yet even this approach has limitations. A small, dark moon may radiate so little heat that it blends seamlessly into the cosmic background, its presence betrayed only by the most careful and prolonged surveys. Astronomers also scrutinize the orbital anomalies of known objects. By closely monitoring the trajectories of near-Earth asteroids and other small bodies, scientists can detect minuscule gravitational tugs, subtle hints that an unseen companion is exerting influence. Each deviation becomes a breadcrumb, guiding researchers toward the elusive target. This painstaking process resembles a cosmic detective story, unfolding over years and decades, where patience, persistence, and analytical rigor are as vital as cutting-edge technology. Despite these challenges, tantalizing hints have emerged. Over the past few decades, astronomers have identified several temporary moons and quasi-satellites, small objects that orbit Earth for months or years before drifting away. Some linger long enough to suggest that a more permanent companion could exist, just beyond the reach of current instruments. These discoveries fuel the hope that our planet may indeed harbor a hidden moon, waiting patiently to be confirmed. The hunt is not just a technical challenge, it is also a race against time. Space is a crowded and chaotic environment filled with debris and moving objects, each of which can obscure or complicate observations. Telescopes have limited windows of opportunity, and the vastness of the sky forces astronomers to carefully choose where to focus their attention. Every faint glimmer, every anomaly in the data must be scrutinized to distinguish ordinary space rocks from a potential hidden companion. The task is immense, yet the thrill of the search drives researchers forward, pushing the limits of what we can detect and understand. Yet the pursuit is as exhilarating as the discovery itself. Each new observation, every subtle clue, brings us closer to answering one of the most captivating questions in modern astronomy. Does Earth have a second moon? And if it does, how did it arrive? What keeps it in orbit? And what might it reveal about our planet, our moon, and the cosmic forces at play in our solar system? The mystery of a hidden moon reminds us that the night sky, no matter how familiar, is full of secrets.
Even within our immediate cosmic neighborhood, objects can lurk unseen for centuries, quietly influencing the delicate celestial dance. The hunt for hidden moons is a testament to human curiosity, ingenuity, and determination, a race to uncover what has long remained invisible. As technology advances and telescopes become increasingly powerful, we inch closer to discovering whether a silent companion drifts alongside Earth, unseen, unknown, and utterly fascinating. And the journey is far from over. With each passing year, new instruments, new surveys, and new discoveries bring fresh insight into the complex web of motion surrounding our planet. Perhaps the next breakthrough is already in the data, waiting for an astronomer to notice the faint pattern, the subtle anomaly, the hidden moon that has silently orbited Earth for centuries. Until then, the search continues, a relentless quest to illuminate the invisible, to map the unmapped, and to reveal the silent wanderers of our night sky.
Just when you think the mystery of a hidden moon has revealed all it can, the universe reminds us that every answer only opens new questions. A secret companion circling Earth challenges our understanding of space, of the familiar moon, and of the delicate dance of celestial forces that governs our planet. But beyond potential threats, beyond irregular orbits and gravitational quirks, lies the awe-inspiring possibility that this hidden moon is a doorway to knowledge we have never imagined. Imagine what we could learn if we managed to study such a world. Even a small, dark object captured in Earth's gravitational web could preserve secrets from the dawn of the solar system. Its surface might carry the fingerprints of ancient collisions, frozen fragments from the time when planets were forming. Its composition could reveal new insights into how celestial bodies interact, how planetary systems evolve, and how objects wander the galaxy before finding a home or drifting endlessly in the void. The hidden moon could even tell us something profound about Earth itself. For centuries, the moon has stabilized our planet's tilt, influenced tides, and shaped life in subtle ways. A second moon, even a small and transient one, could subtly affect Earth over millennia, leaving traces in the fossil record, in the patterns of tides, or in the orbits of satellites that humans have launched into space. Its influence may be faint, almost imperceptible, yet it reminds us that the cosmos is never static, and that even the smallest objects can shape the world in ways we have yet to fully comprehend. And then there is the philosophical impact. The idea that Earth may harbor an unseen companion challenges the sense of certainty we often cling to. It reminds us that the universe is vast, full of hidden worlds, moving silently and without regard for human expectations. We live on a planet that seems familiar, but even here, in the night sky above our heads, there are secrets we have only begun to glimpse. It humbles us, inspires wonder, and fuels the eternal human drive to explore. Even more tantalizing is the possibility that hidden moons could harbor conditions conducive to life. While small and far from the warmth of the sun, internal heat, frozen materials, or chemical processes might allow microscopic ecosystems to survive. Could life exist, unknown to us, on a world drifting silently beside Earth? It may sound improbable, yet the universe has consistently surprised us with its capacity for the extraordinary. As we draw this journey to a close, the hidden moon remains elusive, a silent companion that reminds us how little we truly understand about the skies above. Its story is unfinished, a mystery waiting for human curiosity, technology, and determination to unravel. And while we may not yet have answers, the very act of searching, of tracking, observing, and imagining connects us to the cosmos in a way that is profoundly human. And here, a broader perspective emerges. The universe is alive with motion, with hidden worlds, with phenomena that challenge everything we think we know.
Stars are born, stars die, and entire planetary systems shift in ways both beautiful and terrifying. If you want to understand more about what happens when a star reaches the end of its life and how these cosmic events shape the universe around us, check out our previous video titled "What Really Happens When a Star Dies?" The story of stars and the secrets of planetary companions are intertwined in ways that continue to astonish even the most seasoned astronomers.